Okay, we continue on to question number 8. It says the total undergrad non-resident tuition and fees cost for students enrolled in 8 credit hours at ASU Polytech is $5,871. That's essentially like a reference point of 8, comma, 5,871. The cost per credit hour is $6.56, so that's like my crock. Part A says if a student decides to sign up for an additional 3 credit hours, how much will their total cost change? So we don't want to know the total cost, just how it changes. We know every credit hour is $656. So times 3 more credit hours, my cost will go up by $1,968. All right, part B says if a student decreases their credit hours by 4, how will their cost again change? And so it's still going to be $656 per credit hour, but in this case, we're losing 4 credit hours. And so our cost is going to go down $2,624. Part C says if a student's total cost increases by $3,936, how does their number of credit hours change? Now we want to know the change in input. And so we take that $3,936, divide by the $656 per credit hour, and we're actually going to get 6. So that means they signed up for 6 more credits. Part D says use the given information to determine now the total cost for 15 credit hours. I'm going to go ahead and I'm going to make a table. I should define variables. So H equals number of credit hours taken, and C equals total cost in dollars. We know 8 credits cost $5,871. They want to take 15 now. So my first step is to find the change in credit hours, which is 7. It's $656 per credit hour, which means that my cost is going to go up by $4,592. It was $5,871, so I add those and I get $10,463. And so that is going to be, oops, I knew something was wrong. Oops. I should just erase. 10,463. Sorry about that. All right, part E says determine a linear function that gives the total cost in $C as a function of the number of credit hours. So here we just need to use one of our reference points with the constant rate of change. I'm just going to use the one given. That way if I made a mistake in part D, I'm not going to be wrong for the rest of it. And that's all I need to do for E. Part F says determine the number of credit hours the student is enrolled in if their total cost in tuition fees is $7,183. So essentially that's my output is my cost. So I need to go find my input. My first step would be to subtract the 5,871 from both sides. When I do that, I get 1312. That's equal to this. If I divide both sides by $656, I actually just get 2. And then if I add 8 to both sides, I'm going to get 10 credit hours. Part G says determine the vertical intercept of the function and explain its meaning using the problem context. So essentially, that is finding my output when the input is 0. When I do that, I'm going to get 623. So my intercept is 0, 623. So essentially, if you're not taking any credits, you have to pay $623. So that makes me think that the $623 is probably like fees for no credits, and then you pay on top of that. And then part H says, assuming you can take a max of 18 credit hours, list the practical domain and range of the situation. So the least you could take theoretically is 0 credit hours. And the most is 18. You probably wouldn't take the 0. You don't want to pay the $623, but I guess technically you could. So technically the least my cost could be is $623. And the most my cost could be is if I take 18 credit hours. So I need to actually use my function and plug in 18 and put 18, and I'm going to get 12,431. So the most I could pay is $12,431. All right, that's my domain and range. That moves us on to our last page. Question number 9 says write the formula that defines a linear relationship. If I'm writing a formula, you know me, I am making, I guess it's B and G, a table. So I would do -3, oh sorry, that's not negative, positive. 3 minus a -2, and I'm going to get 5. I'm going to do -2 minus 8. I get negative 10. So my change in output over change in input is just going to be negative 2. Pick one of your 2 points as your reference point. I told you before I tend to pick the one. I guess they both have a single negative, but I'll go with the second one. So I'm going to write it like that. You could use your other reference point. That's totally fine. All right, question 10 says, given the table, which contain values that can define a linear relationship. So remember, a linear relationship is a constant rate of change. So really, I need to go find a lot of changes. So all of these changes. All right, change in D, change in C, change in B, change in A. So negative 0.5 minus a negative 4 is actually going to be 3.5. 1.9 minus a negative 0.5 is 2.4. Negative 19.55 minus a negative 72.4, 52.85. 16.69 minus a negative 19.55. I'm just going to do all of these over here. So 2.9 minus a negative 7, 12 minus 2.9, negative 18.36 minus 54.9, and negative 95.6 minus a negative 18.36. So then we need to find our changes. So change in B over change in A. Are those going to be the same? So 52.85 over 3.5. Is that the same as 36.24 over 2.4? I'm going to get 15.1 for this one, and I'm actually also going to get 15.1 for this one. So yes, this first table is a linear relationship. For the second, same thing with my new ones. So negative 73.26 over 9.9. Is that equal to negative 77.24 over 9.1? I get negative 7.4 here, and I get negative 8.49 here. So those are not the same. So then part B just says, for each linear relationship, write the formula. So I know my CROC is 15.1. I just need to pick one of those reference points. I'm going to pick the last one because there's no negatives. And there we go. All right, last question. So the total distance you are from Yellowstone National Park, D, with respect to the amount of time since you left Cheyenne, Wyoming, and T can be modeled by this function. Identify the constant rate of change and interpret its meaning using the problem context. So negative 74, and the units are that. It's always output with respect to input. So D is distance. Oh, it doesn't even tell us. Let's assume it's miles. That's a problem. So this is going to be miles, and then it's going to be per hour. And so essentially every hour, your distance, oops, that should not be there. Your distance from Yellowstone decreases by 74 miles. You're getting closer. And then my reference point is going to be 2.6 comma 236.6. So after 2.6 hours of driving, you are 236.6 miles from Yellowstone. That sounds so fun. Let's go right now.